contrast to a sweltering March last year, this year the US suffered through nail-biting cold. In fact, much of the Northern Hemisphere was buried under record-breaking snowfalls. How can global warming possibly explain that? To understand how, you need to consider the basic drivers of climate. As the sun heats the Earth unevenly, it sets up temperature gradients on many different scales. These create the winds and currents that influence weather.
All the ocean currents are driven by basically the temperature gradient between the equator and the pole, and it's the same in the atmosphere.
The atmospheric gradient between the tropics and the poles creates the major westerly winds called jet streams. Wind rushes down a slope from a warm, puffed-up atmosphere to a cold, compressed atmosphere.
The stronger that gradient, the stronger the force that wind is being pulled by, if you will, and then because the Earth is spinning, instead of flowing directly from the south to the north, it actually gets turned to the right by the spinning of the Earth.
These fast-moving wavy winds encircle the northern and southern hemispheres and mark the divide between cold polar air and warm tropical air.
They swing north and they swing south, and the weather that you experience is completely related to where you are relative to one of these waves.
But what happens when you mess with the temperature gradient? It's a hotly debated topic, and right now we're running an extraordinary real-world experiment by turning up the thermostat in the Arctic.
It's hard to get your mind around how fast the Arctic is changing. It's really mind-boggling, even to someone like me who's been studying it for decades now.
The Arctic is warming faster than anywhere on Earth, largely to do with the feedback effect of melting sea ice. White, bright ice bounces the sun's rays back into space before they have a chance to warm the surface. But when a small rise in temperature melts some of the ice, the dark ocean below is exposed. This absorbs almost all the sun's energy and heats up, causing more ice to melt, leading to more warming, and so on.
What we're seeing is the Arctic sea ice disappearing at just an amazing rate. This is the ice that's floating on top of the Arctic Ocean. This past summer, it was half as big as it was only 30 years ago.
Research by Dr. Jennifer Francis has shown that Arctic summers with a low sea ice extent leads to a gentler atmospheric gradient.
The force that's creating those winds in the jet stream is getting weaker as well.
Like fast-flowing mountain rivers meander when they slowly cross the coastal plain, Jennifer predicted a weaker, slower jet stream would display a much wavier pattern.
We were able to determine that, in fact, these waves are actually getting larger in the north-south direction, which we know through weather theory that those waves then tend to move more slowly from west to east.
And a lazy, meandering jet stream can have an extraordinary effect on weather.
A big dip south, for example, will allow that cold air from the Arctic to plunge farther south. And conversely, if you have a big swing northward in one of what we call a ridge, then that allows the warm tropical air to extend farther northward. So in both of these cases, we tend to get more unusual weather patterns setting up.
That's exactly what happened when frigid Arctic weather plunged into Europe and southeastern US this March, bringing record snowfalls and leading many to wonder what happened to global warming. The year before, the US was caught in a jet stream upswing. Unprecedented heat smashed over 1,000 temperature records and set the scene for a staggering drought and massive agricultural losses. This decade, the Northern Hemisphere has seen some catastrophic results from a highly deformed jet stream. While a big stagnant high settled over Russia in 2010, cold air from Siberia plunged into Pakistan, colliding with warm, wet air from the Bay of Bengal. As Russia burned, Pakistan drowned under a deluge that lasted nearly 2 months.
As the jet stream takes on this wavier character, what this means is that the weather that you're experiencing in your location is going to stick around longer. It's going to feel like those weather conditions just won't give up and bring something else. It feels like it's stuck.
How jet streams are being affected by a warming Arctic is still highly unpredictable, with many other interactions affecting their speed and movement. But one thing's certain: we'd better get used to wacky weather.
When we talk about climate change in the future of 1, 2, 3 degrees, it's actually hard to imagine.
It's going to be a difficult next few decades, I think.
When it comes to extreme weather, the connection is pretty clear. The warmer the world, the wilder it gets. And with the speed that emissions still enter the atmosphere, we're right on track for an unrecognisable future.